Hi, I'm Dan Gardner, Technical Marketing Engineer with HPE Storage. When ransomware strikes, it can be all hands on deck. The last thing you need is to worry about whether your backups have been compromised, or spending valuable time figuring out when the encryption started, or when a system was infected. After all, ransomware gangs often let their malware lie in wait, deleting or corrupting backups before encrypting your files. Here at HPE, we've introduced a new ransomware detection feature to the HPE Alletra storage B10000, which builds on the encryption detection technology in HPE Zerto software and provides real-time encryption detection on any block storage workloads. And when you combine this with a robust protection policy using HPE Virtual Lock to create immutable snapshots of your volumes, you can be sure that your backup data is safe from deletion and provide the ability to recover from a ransomware incident quickly, efficiently, and with minimal data loss or downtime. In this demo, we're not only going to cover the ransomware detection feature and see it in action, we're going to show the whole picture, from alerting via syslog when encryption is detected, to scanning snapshots for malware in advance of data recovery. Here we've got our four key players. Top left is our victim machine, top right the B10000, bottom left is our cloud-based Elastic SIEM, which has been pre-configured to receive security syslog messages from the B10000 and send email alerts at any ransomware detection events. And in the bottom right corner is our malware scanner host, to which we can export physical copies of the snapshots, mount the file system, and scan for malware. So, let's dive in. On our Windows victim, I've preloaded a corpus of sample data from GovDocs, which is a free online resource providing 1 million documents of varying file formats for research purposes. And over on the B10000 UI, we can see the volume where the victim virtual machine is stored and that ransomware detection is enabled. I've also set up a protection schedule on this volume to create daily immutable snapshots using HPE Virtual Lock. Back on our victim machine, it's time to launch the attack. For this demo, I'm using a script which simulates a ransomware attack, but in our test labs we've already tested the detection feature against many real ransomware strains to help fine-tune the detection algorithms as part of an ongoing effort to provide the best detection possible. As the script runs through the specified directory, encrypting each file individually, we can see the disk write speed start to jump up. Traditional ransomware detection generally relies on malware signature detection and file extension scanning, data reduction efficiency, CPU utilization, or fixed threshold data entropy calculations. Unfortunately, these traditional detection techniques are no longer sufficient to detect modern ransomware, which can employ many tactics to evade detection, such as only encrypting part of a file, enough to render it useless, but not enough to show as significant for backup size or data reduction calculations to detect. The data adaptive ransomware detection in the B10000 uses two independent algorithms, which allow for dynamic calculation of trigger thresholds, which greatly enhances the accuracy of detection and reduces the number of false positives. The detection runs as an inline process, analysing the write data path as cached memory pages are destaged to the physical drive, and this happens before any data compression, deduplication, or on-drive encryption takes place. Ransomware detection on the B10000 comes as standard in the 10.5 release of the B10000 OS. No additional licenses are needed, it can be used in disconnected or air-gapped environments, and has a negligible impact on performance. For a deeper dive into how this feature works, I'd recommend reading the B10000 ransomware detection technical white paper. Over in our demo, I've shortened the sequence and skipped to just before the encryption has exceeded the threshold for the alert to be triggered. As you can see, the B10000 UI shows the volume is degraded, an alert is generated, simultaneously pushing those alerts to the Elastic SIEM, which also triggers an email notification that highlights the affected system and the affected volume. When the B10000 detects potential ransomware activity, it does three things. First, it marks the volume as degraded. Second, it creates a short-lived, immutable snapshot of the affected volume for use in incident analysis and forensic investigations. And third, it creates alerts of the detection and the snapshot creation, which are sent to the security syslog, data services cloud console, and if call home is enabled, straight to HPE support. The alert snapshot by default has a retention time of 48 hours, which should be sufficient time to take action without having an impact on capacity. The snapshot should never be used as a recovery snapshot, as it will contain data that triggered the alert. But it is useful for forensic analysis. Additional alert snapshots won't be created for the affected volume, even if more detection alerts are generated, as they'll only contain more encrypted data and increased capacity usage. Back in the demo environment, I've created a physical copy of one of my snapshots and exported it to my malware scanner host, which is running Debian OS and has Sophos AV installed. As we're working with a VMware VMFS volume, I've taken our exported volume from the B10000, located on Empath B, and mounted it using VMFS6 tools so the file system can be read. If we list the contents of the mount directory, which I forgot to use sudo for, so I'll just quickly switch over to root. We're looking for the virtual hard drive file, which we could then use kpartx to mount the partitions from the disk image file into the device mapper, and I've already done this prior to the demo. Using fdisk, we can see that the vmdk file has 5 partitions. And we're looking for the C drive, which is where I know the malware is on the machine, because I put it there. So I've mounted partition 3 to the vmdk1 folder already. Digging into the folder, we see everything we'd expect from a Windows file system. And now that the drive is mounted, we can use our malware scanner to inspect the drive. Logging into the Sophos antivirus scanner, I'm setting the reporting level to just tell me about any viruses detected and to display the outputs in XML format, which is a little bit more verbose than the standard brief setting. I've instructed it to scan the user1 folder recursively, as I know that's where the malware is, and to keep this demo from running on too long. But ideally you'd scan the entire drive contents, but it will just take some time. As we leave the scanner to do its thing, we can see that the syslog alerts are still rolling into the Elastic SIEM, and the encryption is still underway on the victim machine. But as we've already been alerted to the ransomware attack and begun the investigation into our backups to check if they're a viable and clean restore point, we're getting ahead of the incident. So as the encryption comes to an end, we're left with the ransom note and decryption instructions, which is fairly standard for any ransomware attack. I mean, luckily I created this script to be able to decrypt as well as encrypt, but so all is not lost. If we go in and then check the files in our target directory, you can see they've been rendered completely unreadable. Returning to our malware scanner, the results have come in, and as suspected, it's picked up some malware. It displays the type of malware, the location, and if it can be disinfected, which in this case it can't, but it can be deleted. So let's close the Sophos session and delete the malicious file. Just checking the indicated folder to make sure the file that was detected is there, and we can use the rm command to remove the specific file. After deleting the offending executable, we can log into Sophos and run the scan again. And we'll run this just on the desktop folder, as that is where the malware was found. This will be fairly quick as it's only a small directory. Here we get a done OK 0000 function call succeeded, which indicates that the directory was scanned and no malware signatures have been detected. This volume can now be exported to a cleanroom environment to boot up the VM and run additional checks before restoring to production. I hope you found this demo useful and learned how the HPE Alletra Storage B10000 can form a vital part in your ransomware defense strategy by providing real-time detection in the event of a ransomware attack. There's so much more to come from HPE Storage to help you keep your data secure, and I can't wait to be able to share it with you.